Hello all, I'm Reed Graff from Wow, okay, let me start. Hello all, I'm Reed Graff, the student coach for team 17682 TimberX, and today we're going to be talking about how about complex mechanisms. So in the previous episode, what we talked about primarily was how to design custom parts for the real world and actually how we can, apply them to the real world. Now we're going to be talking about complex mechanisms. So these are important to notate because a lot of the times, because in FTC we can only fit within an 18-inch cube box, a lot of times we need to extend outside of that. So for example, this year in Power Play, what we have to do is pick up a cone and then lift it to a pillar or junction that's, I think, 32 or 36 inches high, which is exceptionally high given that you have the 18-inch sizing box. So in order to do that, there are a bunch of different mechanisms that we should be familiar with. So one of the mechanisms is Bendy straw, which is kind of just esoteric, but outside of that, we have our linear actuator right here, which can be controlled via a screw or via hydraulics or pneumatics. Here we have a linear slide, which is exceptionally common. And here we have a scissor lift, and there are also other ways to extend using like 4 bars or virtual 4 bars using chains, and a bunch of different other ways to extend. But I'd say the linear slide and the scissor lift are probably amongst the most common. All right, so this is another example of scissor lift, as you see like on a bunch of forklifts before maybe, or on those lifts that go up to clean windows, for example. That's kind of how they're driven. You've probably seen these a lot before. They have like scissor motion, and they can be controlled via hydraulics going from one side to the other. Unfortunately, hydraulics and pneumatics are actually banned in FTC, but in FRC, this is an example of what you can do. But you can control it. You can make a scissor lift still and have it be controlled via a motor or a screw system. So this is a rack and pinion, or also known as that other thing, and I was supposed to put a subscription here, but I didn't do that. Regardless, this is another more advanced mechanism that you maybe aren't familiar with, where you have a gear here and it's moving a rack. Either this gear could be in one place and this rack could be moving, or vice versa, the rack could be stationary and the gear could be moving along it. And now here's the linear slide. This is an example of one linear slide that we actually have. Where a string goes up through these different corridors and has this, and where it can move up and down, and this is controlling it that way it doesn't extend too far. And then once we rotate it, it'll go up, and once we rotate the other way, it'll go down. All right, this is an example of the actual linear slide that we made ourselves. It's more of a simplified version, so it can actually go up without a problem, but in order to go down, the string has to be loosened. Here's a linear actuator that's screw-based, or pneumatic. So how about extreme complex shape development? So there are a bunch of examples and mechanisms. Here's an actual repository for mechanisms for FRC, which gives you some things to reference when designing yourself, and allows you to kind of think outside the box as well. There's also Disney manufacturing tools and papers on using AI, well, not even necessarily AI, but just programs and math to actually make things for you. So for example, in these papers, they outline a movement that they want a robotic organization to make. And then they use math to make different gears and levers and arms and whatnot to actually follow that shape and path. And here we have a paper here, YouTube video, as well as one with wires, flexure, and soft robots. This is Fusion Automated Manufacturing. So this is just other tools integrated with Fusion that will help you in your design process. And then here's finite element analysis. So what finite element analysis is, it effectively turns your model into a bunch of cells, and then doing that, you're able to calculate, given different parameters of the materials, you're able to calculate how much stress it would take in order to bend it, how much stress it would take to break, the tensile strength, other identifying factors like that way you know whether or not your part is going to break or not. And this isn't necessarily for FTC. You're usually not going to be going under enough stress or enough, aren't really going to be doing something that is going to kill someone. But when you're doing something like designing a ski lift, then it's important to do FEA and other analysis tools. CFD is computational fluid dynamics, and that's very important for plumbers or things like engineers for petrol. And that's where you effectively simulate water or fluids, any fluids going through a tube or just around, or you can do a fire or something to that effect. Is also important for aeronautical engineers who are designing engines for space and whatnot, jet engines generally. This is Mechanisms and Dynamics of Machinery book. And this is just important to reference. This is a very famous book for mechanical engineers. It's very good to reference. There's a Google Drive link for it right there. We actually have this plastered all over our robotics room just for inspiration. This is another very, very famous mechanical engineering book. There's, once again, a link right here. It's called 507 Mechanical Movements. All of those of which are important in dynamics, hydraulics, hydrostatics, pneumatics, steam, engines, mills, and other gearing processes, presses, horology, and miscellaneous machinery. And then finally, there's mechanisms and dynamics machinery. So this is more modern, covering more modern machines and how they work exactly, the different parts of them. Once again, another Google Drive link. And then other things that you should familiarize yourself with in Fusion is the sweep function, the project function, the plane temp function. Unfortunately, we didn't actually make slides for this yet, but hopefully we'll be covering that in the next videos. This was Reed Graff from TimberX Team 1762. See you next time.